All right, back for part two. Here, just asked to do calculate some values given a function in factored form. See, we could graph this, and we will at the end, but for right now, we're just asked to calculate some values. So here we could use the graphing calculator, and we could use the value function or the table function, but I'm going to practice this fraction business, and I know I could use 0.5, but I'm gonna, because it could be 2/3 or something like that, I'm gonna try and do this on my scientific calculator. All right. Well, here we go. So if x is a half, I got 1/2 bracket times bracket 1/2. And again, I'm doing that instead of 0.5, because if this was 2/3 or something different, then we want to be exact. Bracket to the exponent 2 times bracket 1/2 minus 1 bracket equals, finally, and I get negative 3.0625. So a x and f at x, a half was, what was that value? Negative 3.0625. Dandy. Oops. Where was it? Nope, not there. Calculator. Okay, good. Minus 1. And again, I could probably do this in my head, but if I use my calculator, watch your negatives. Should be in brackets still. Some calculators, like I think this one, I got to make it negative after. Times bracket negative 1 plus 3. Easier to do this in your head, I think. To the squared times bracket negative 1 minus 1 and bracket equals 8. That's practice using our scientific calculator, but there we go. F at a half equals negative 3.0625. F at negative 1 equals 8, and there's our function notation if we'd like it. State the domain and range of the function. Well, this is more difficult, you know, because just thinking of the sketch here, and I'm going to have to do this in E, but 1, 2, 3, 4, it's a degree 4. Starts high, ends high, and you know it's a W shape of some sort, and we'll get the details when we get to the sketch. You know, I can see that the domain is just going to be all real numbers, right? I can take any x value I want and shove it in there, but the range, it's probably going to come down to the end of one of these W shapes, and the range is going to be everything above that. So it's really important to know that minimum. And so I'm going to use the graphing calculator and find the minimum of that bad boy. All right, graphing calculator. Again, the steps are earlier, and I'm going to go through this as fast as I can for you. Clear that off. X bracket x plus 3 squared times x minus 1. And I'm hoping that Zoom standard will be a decent window start. And it's perfect, right? I can see it starts high and ends high just like I expected. The minimum I want to find is that right there, right? So I can say anything above that is the range. So I'm going to go second trace to get the minimum. And then follow the on-screen instructions. Left bound, this is okay because it's to the left of the minimum I want to find. And then I'm going to scroll to the right. It doesn't matter how far I go. And then back a guess that's close. And so I'm going to write that down. I'm going to write that minimum down here. Was 0.54? think. 0.57. Negative 0.57 and negative 3.12 was that minimum, right? And so the range is anything that's above that, right? Because it started high and end high, opens up like a parabola with a positive leading coefficient. So the range is, well, the x values I don't care about. That's the absolute minimum, isn't it? So y has got to be greater than or equal to negative 3.12, about, right? And that's the range. Notice that in part C, we want to state the coordinates of all relative and absolute minimums and maximums. Well, we had the absolute minimum already. Absolute minimum was 0.57 and negative 3.12, and now we got how many more to go? Well, we've got that maximum, which it's not a nice point. I'm going to have to do that one. But I see that this minimum, which is a relative minimum, I can read right after the graph, and that's negative 3, 0. That's where it bounces on the x-axis, right? So I'm going to say a relative minimum is at negative 3, 0, and I just read that, straight from the function. I know it's going to bounce there, right? So that's how I knew that. But for the other one, the relative maximum right there, I'm going to use the calc menu, find a maximum. And I want to go to the left of it, so maybe negative 2 is to the left of it. Yeah, and it is. And I'm going to scroll a little bit to the right of it. And then the guess is in between. And the relative max was, what was it? Negative 1.32 and 8.64 about. Okay, and that was it, right? We had, this was just our early sketch. That wasn't what it looked like at all. 1, 2, 3 minimums and maximums, 3 turning points. We got our zeros, we can see, and now we can do a sketch, right? I'm going to do a sketch. Part D here. Well, I know it's degree 4. Starts high and ends high because the leading coefficient is positive. And I know x-intercepts at 0. Minus 3 is a bounce, and 1 is a slash. So 0. 1 minus 3 is way over here, say. And I don't really care too much about the scale. Starts high and ends high, like this. Bounce. Slash. Slash. That's all good. And now let's put these other things on here. This relative maximum was negative 1.32 and 8.64. And this relative, this is the absolute minimum, is 0.57 and negative 3.12. And that's dandy. All right, last example. After the driver of an SUV applies the brakes, the position of the vehicle is given by that function, where t is in seconds and the distance is in meters. How far does the SUV travel in after 2 seconds? That's not very hard, is it? That's t equals 2, so I just want to calculate when d at 2. Point 1. Messy. And then 2 squared, right? And fire that into a calculator. You get about, well, let's do it. 2 times 2 times bracket 14 minus 0.1 times 2 squared n bracket equals 54.4 meters. The SUV 54.4 meters away. What's the maximum distance the SUV reaches? Well, that we need a graph or a graphing calculator. So fire up the old TI-83 again and clear out the old stuff. I'm going to put in 2 times x bracket 14 minus 0.1 x squared n bracket. Then when I press zoom 6, I get this sort of not very nice graph. I can't see what's going on. Well, what's happened is this graph is growing too fast. I need to change my window setting. So, you know, what the x values are, well, I don't know. I didn't see it come back down at all, but I need to see how high this thing's going. So I might try something else. Maybe I'll put in 100 here instead of 10. Each tick worth 10 and see if that works better. Well, that's a little bit better, and I can see it starting to come down. So I might want some more x values, and I don't need all these negative x values, so I can change my window settings here a little bit, right? So maybe I'll start at -2 and go to 15, say. And maybe I'll go up to 200. Go up by 25s each tick instead of 10s. Let's see how that looks. Well, there's the maximum right there, right? Maximum's right there, and the window settings look nice now. And I can find that, right? The maximum is just second calc maximum. And then notice I'm pretty close to it. That's just by chance. I'm going to go a little bit to the left, make sure I get my maximum there, a little bit to the right, right bound. And then the guess in the middle. X is 6.83, Y is 127.5. So the max is at 6.83 seconds, 127.5. So the SUV reaches 127.5 meters after 6.83 seconds. Now I want to mention something. That's it. That's all we had to do. But this is a little bit of a silly model because notice this is the SUV's traveling away and is braking, slammed on the brakes, but still moving away, and then finally stops. The weird thing is after that, the distance starts decreasing. It's like the brakes are pulling the SUV backwards. So this part doesn't make any sense at all. That the SUV would start traveling backwards, and in fact, later on, right at this spot here, it ends up being back to the spot where they started. The distance becomes 0. From here on in, from right here, I'm going to take a picture of this and start marking it up because this is a bit silly. Right there, that's the maximum, right? That was that 6.83 and 127. It should have stopped, right? The distance should have stayed there. And this was inappropriate to use this because it's not like the SUVs start gonna, gonna be moving backwards. Maybe if they slammed it into reverse, it would start going in backwards. But if this is just the brakes, it should have stopped and started stayed at 127.5. This was an inappropriate inappropriate use of this model. In fact, here we could say that the domain could be restricted, right? The domain should be, you know, anything at 0 is when they started applying the brakes, and then 6.83 seconds is when they stopped, and anything outside of that range just doesn't make sense. And that's where we could have a domain restriction, is in an applied setting like this. All right, a little bit of an aside there. I don't think you're asked to get into that much detail in your homework, but have fun with that.